Thank you very much. So yeah, my name's Katie. I do far too much stuff. So if you want to talk to me about any of the stuff that I do, please come and find me afterwards. But I'm going to try and restrict this to a subset of the things that I do, which were specifically the big things, because they are, let's be honest, the best things. I also do basically anything you've heard of that's got the word maths in it. So I help to run Maths Jam. I help Matt with his website, Maths Gear. I do maths talks, and I did a podcast. I've done basically a lot of things. And I know quite a lot of people here, so come and find me if you don't know me yet and introduce yourself, because that will be helpful. So I've done a few, mainly this is basically Matt's fault. Most of what I'm about to say is Matt's fault, but I've done quite a few sort of large-scale maths participation maths projects, and I thought it might be useful to share with you some of the things that have happened and how it worked and what was useful and what went well, and what didn't go well, so that you guys can take that if you ever find yourself in the situation that I do. So the first one that I was going to talk about was our Domino Computer. Which, yep, you can put those two words together, it turns out. So in the same way that a lot of people will stand up kind of rows of dominoes to create an entertaining domino run, you can also do computing with them. So you can build, for example, an XOR gate. Sorry, this is an OR gate. This is this very simple one. So this is an OR gate which will, if you bump either of the inputs, give you an output. Those are Matt's fingers. And he's in all of these talks. So you can actually use this. You can build more complicated things. So you can build a binary half adder. So if you're familiar with how logic gates work, this is a binary half adder. It's got an XOR gate here, and it's got a nice little kind of knocky-outy bit over there. But you can do various clever things with these, which will then give you a kind of a pair of outputs for digits of binary. And you can combine these in different ways to create domino computers. So in 2012, we basically put together a team of volunteers. We put together a large pile of dominoes. This was because, and I realise this has just been mentioned by Matt, this is because Matt won the Joshua Phillips Award in 2012. And because of that, we were given some funding to run an event, and Matt said, run an event. So I went and bought 10,000 dominoes, and we kind of put a team together. We designed this computer, we designed the layouts of all the circuits. We had a testing weekend where we practiced and built a test domino computer. This is kind of the amount of excited I was at the test weekend. By the actual event, it was like 1,000,000 times more than that. And we did have a really good event, so we got some filmmakers that we know to come and do a little video of it. It's about 20 minutes long, but if you search for domino computer, it is literally the top result. You can see that Matt is here explaining that while most people tend to build computers out of circuitry and wires and boring things like that, we're using dominoes. So it was a really interesting weekend. It was at the Manchester Science Festival. Basically, this was quite a good project in terms of kind of getting people talking about it. So we had basically a crowd of people watching us the whole time. I don't know if they were just waiting for us to knock some over and an exciting spill to happen. But because we were there kind of laying out the whole thing, stacking up all the dominoes, putting it all together for the whole weekend, people who were visiting the Science Festival came and watched. When we actually did the final thing, we had quite a big crowd watching. So this was the audience at the end of the day when we'd built the whole thing. This is a four-digit output, three-digit input. So we can, if we want to, add up two numbers as big as 7. And this took about 6 hours to put together. This is the problem with domino calculations. I think we calculated the kind of calculation speed of this compared to a regular computer, and it was in like nanohertz. So it was amazing. But yeah, basically this was, I think this will run actually. Oh, it's got the sound. I'll turn the sound off. We counted down from 3 in binary because we're like that. And then we set this whole thing off. I actually got to nudge the first domino, which was basically, for me, that was the main benefit of the entire project, was that I got to stand there and like knock the first domino over. But this was the layout that we had. And I'll just leave you to watch that while I explain some more things. The only thing about this that I wasn't as happy with was that a lot of people couldn't join in. So we had kind of tables nearby where people had kind of small sets of dominoes and they could practice making different logic gates. We had a set of resources for schools with some videos and worksheets that they could do to kind of play around with this kind of thing. The problem being that you need a lot of dominoes to make this work. We still have 10,000 dominoes, by the way, if anyone wants to borrow them. We're basically currently in a school. We're sending them to different schools as and when they request them. So if anyone does want to kind of recreate this, you can borrow the dominoes. But they're very good dominoes for kind of balancing and knocking over. And we're just in tears at this point because that worked. The second day it didn't work. Which was a combination of trying to build a bigger computer in the same amount of space and resulting in signal bleed, which is actually a problem that actual circuits have, which was quite nice. And we also mistimed one of the sections, so there was a run of dominoes wasn't long enough, so it got there before the bit that was supposed to get there first. But it was kind of, it was very much just us building the computer and people watching. And, they would come and talk to us, ask us questions about it. And it was a really nice project just because it was such a crazy thing to do. And I got a sense that it was worthwhile because a kid came up to me and was like, what are you doing? I said, well, do you know how computers work? And he said, yes, you move the mouse and the pointer moves on the screen. And I think that illustrated for me, okay, you don't. Let's do some more outreach. This is needed. So yeah, that was part of the Manchester Science Festival, and it was funded by the fact that Matt had won the Joshua Phillips Award. So that was 2012. The following year we were very tired, so we didn't do anything. Actually, that's a lie, I did everything else. But in the 2014, we decided it was time to do something again. And I think possibly the Science Festival came to us and said, that thing was good, do another thing. And it was a combination of that, and Matt ran into Laura Talman, who worked at the Museum of Math in, the one in New York, the one that we're here because of. And they were basically chatting about fractals because that's what happens at the Gathering for Gardner, which is where they were. And that resulted in the Menger project, which some of you in this room, I think, took part in. If you did, come and find me afterwards so I can give you a high five, because I'm very happy that everyone got involved with this. But basically, this is a Menger sponge. Hopefully you've seen one before, named after this guy. And incidentally, his granddaughter actually got in touch when we were doing this project and was like, I hear you're doing a gigantic sponge. But we basically, so it's a cube with the middle section taken out in each direction, and then each of the resulting smaller cubes has the middle taken out in each direction and so on. But rather than building one by taking a giant cube and kind of hacking away, we started with individual cubes. So there's a really nice way to make a single cube out of 6 bits of card, which looks a little bit like this, and you can then assemble them together, and you can cover the outside with pictures of the outside of a Menger sponge so that it looks like you have a tiny fake Menger sponge. And this is the least impressive Menger sponge, but it is, because it's a fractal, it contains all of the complexity of the whole thing, so I don't know why you're not impressed. But this is a single cube Menger sponge, or level 0 as it's known. You can then take 20 cubes and build them together into a level 1 Menger sponge. You can then take 20 of those and build them into a level 2 Menger sponge. And this was one that I built on my coffee table in my house. We also built this one at the Museum of Science and Industry in Manchester. These guys just built this one in their office when they were meant to be working. We just got local businesses involved. We got a few more that were built at various different events at the launch party for the Science Festival. Local schools sent in a few of them. And essentially over the course of the weekend of the Science Festival, we put together a gigantic Menger sponge in the Museum of Science and Industry in Manchester. We got t-shirts, it was amazing. So we had members of the public coming in, each of them could build either one individual cube or build a level 1 and kind of contribute that and put it into the pile, and we would build them all together. And it was really nice because we had loads of information sheets, we had kind of posters and things about fractals, we were getting people involved, and it was really visible, so there's definitely something going on. We had camera link-ups with some other places, I'll come back to that, but this was the Manchester one. The reason I refer to it as the Manchester one, I think there's a slightly nicer picture from another angle, is because it was not the only one. And that's why it was the Mega Menger. It was very much not just a single Menger. And the idea was that in theory, if we have 20 of these, that would constitute a level 4 Menger sponge. So we basically emailed everyone and said, would you like to do a ridiculous thing? We printed up a load of cards and posted them out to everyone. So we had this one in Finland, this one is in North Carolina, this one was in Canada at the Perimeter Institute, Michigan, Alabama, Georgia, that one is in Colorado, this one is in Edinburgh, I think that one's still there, can't remember. Yeah. That one's still there, good. This one's in China, this was in a school, it got national coverage in China, it was terrifying. This is the one in Bath, there's some familiar faces in amongst here. This is the one at MoMath in New York. This one is in New Zealand. It was built in an art gallery, which is really nice. They didn't get the New Zealand one finished on the day that they set out to do it. And at the end of the day, I got an email from the organizer, who's someone that used to live in Manchester and moved out to New Zealand, so I know her. And she said, we had a fantastic day. We got loads of people in talking about maths, got learning about fractals in this art gallery where people weren't necessarily expecting to encounter maths. And we had a fantastic day and everyone had a great time. But I'm really sorry, we didn't manage to finish it, and I know that was the point. And it's like, oh, well, it really wasn't, but I love you. Yes, they have since finished it off, basically. I think what happened was they built, like, the front part of it, and then they came in the next day, and the cleaners had tried to move it, and, like, broken it. So they had to then transport it back to the maths department and try and recreate what they'd done and then complete the whole thing, which is fantastic. This was the one in Spain, which I think wasn't quite finished at the same time as all the others, but they were also building a giant Sierpinski carpet at the same time, so I forgive them. This is one in Cambridge, which is still there. You can go and see it. It's in the Centre for Mathematical Sciences, just tucked round the corner. This was one built in a school in Cumbria, which, again, they didn't quite manage to finish, but they did genuinely keep this in the cupboard for quite a long time, because we went there about a year later to build a Domino computer with them, because this is a fantastic maths teacher that does loads of stuff, and he just pulled out, he's like, I've still got this stuff, should we put this together and get photos with it? And the one in Leeds, which I believe is now coffee tables, is this true? I need to see these. I'll go and visit them, but apparently each of these has been encased in perspex and is now a coffee table. And of course, this is the one in London, which I suspect is possibly the most important one, because it was at Queen Mary who gave us the money to print 1 million business cards and post them out to everyone. So thank you very much to Queen Mary for funding that one. Essentially, we set out with no plan, and Matt, who has connections at Queen Mary, basically asked very nicely, and they were like, yeah, okay. And we're like, whew, my goodness, we've got money to do this project, which was fantastic. There's a little map on the website of all of the locations where we built Menger sponges, which is very reassuring to see how far this has spread. So the big red ones are the big level 3 Menger sponges that we've just seen. There are also level 2 Menger sponges, which are the kind of half-a-metre ones, which were done in schools in different places, and they sent in photos. And I've also included anyone who just made a level 1 Menger sponge this big and sent me a tweet with a picture of it. I've just put those on as well in the approximate locations that they're from, because I wanted to kind of get a sense of how much it was. We didn't actually get fully 20 big level 3 ones, but if you add up all of the smaller ones as well, it counts as a level 4. So that was a success. And this was, I think this was a lot more kind of participatory than the Domino computer. Certainly everyone could come along and get stuck in. Everyone could see the thing occurring as it happened. So that was one of the things about it that I thought was quite nice, that it was quite a visual thing. It was something that kind of, non-mathsy people who were maybe artistically inclined could come along and say, oh, these fractals look nice. Can you tell me more about this? And we had kind of posters of different fractals there and various discussions around kind of, the uses of this kind of maths and things like dynamical systems and chaos and fractals and the way that these things are generated. So this was quite nice, and I think a lot of people have heard the word fractal but don't necessarily have any idea what that means. So this was quite nice to open that up to people. If you want to find out anything about this, there is a website at megamenger.com. And all of the details are there. There are also worksheets and instructions on how to build the Menger and some other fractal-related worksheets as well that we put together for the project. So that was like 6 months of my life. I'm still getting emails now. I got an email the other week from a guy in Poland who was like, we've built a level 2, can it go on the map? And that's still happening. That's genuine. And I also got an email from someone who said, I would like to build a level 4 Menger sponge. I was like, no, you don't. You do not want to do that. He's like, well, how many cards would it take? I'm like, 1.35 million, don't do it. But I don't know, because he was just continuing to ask more questions about how this could happen. Anyway, I've got 7 minutes, right? That's true. So I'm going to use these 7 minutes to tell you about the next one, which hasn't happened yet, but is in the process of very much happening in my brain right now. So the Manchester Megapixel, which is the 2016 project. So if you've ever seen, occasionally Matt and myself do a talk about maths and technology, one of the things that kind of features in the talk is this spreadsheet. If you have seen this spreadsheet before, then hopefully you'll enjoy this, but this is a spreadsheet containing pixels. The numbers in the spreadsheet range from 0 to 255, and using some slightly clever conditional formatting, we've made it so that the brightness of the square depends on the color, on the number in the cell, and the colors just go red, green, blue all the way down. And if you zoom out from this spreadsheet, if I gradually zoom out, you will find this is not just a spreadsheet, it is a photograph, which is very nice. And it's also a photograph of Matt, which is even better. So This seems like a ridiculous thing to do. We've got kind of rows of red, green and blue, and each of those is a different brightness. But if you take a microscope and place it on the screen of a laptop, so this is my laptop, this is literally this screen, although not while it was showing that would be weird. We tried it, yes. And this is a mobile phone. So a lot of systems do actually use this idea of having a red spot, a green spot and a blue spot in kind of 3 rectangles. And if they vary the brightnesses of those spots, it will give you different colours. And given this, we thought it would be a good idea to try and create this by hand. So we have acetate pixels, we have red, green and blue pens, and we have a gigantic window on the side of the Museum of Science and Industry in Manchester in which they're going to let us sellotape up thousands of pixels and create a gigantic photograph and put some lights behind it and create a massive analog digital display screen. So we've got a lot of pixels to colour in and stick on the window. And we've done some testing. So we've done some preliminary testing. Here is me and Matt with a thing that kind of looks like something, which we're very happy about. But the idea is that when we're going to send out pixels to schools beforehand so that they can colour them in and post them back. And then we're also going to have people at the museum during the Science Festival also colouring in pixels. We'll have various activities around it that people can learn about how displays work, what the maths behind all of it is, and how what we're doing is actually going to result in a thing. And I'm hoping that we can create a gigantic photograph. We haven't yet announced what the photograph's going to be of, but hopefully that will be soon when we've decided. No, I think we've decided. And we're going to post out schools packs. They're also going to include worksheets and activities around it. We've got one of my favourite activities is the shining 3 different coloured lights onto a thing, which is going to be fantastic. The Manchester Science Festival is supporting it. The University of Salford has also chucked in a pile of money, which I'm very happy about. And of course, Edding, which might seem like a slightly off-the-wall sponsor, but they've just given us 2,000 pens. They've literally given us 2,000 OHP pens in order to be able to actually do this. So I'm hoping that this will again have the sort of participatory feel to it. It will be something that will get kind of interest on social media, which is something that we've done with the Menger project as well. This isn't my bottle of water, is it? Did I just take the lid off that and it's not mine? I'm just going to put the lid back on. No, I've got one in my bag, I'll be fine. I just really need a drink of water. People will be able to get involved on the day if they come to the Science Festival, but hopefully they'll also find out about it from elsewhere. We're hoping to get a bit of kind of social media and media coverage to kind of get people talking about it, because it's very silly again. So again, if you want to find out more, the website is manchestermegapixel.com, and the schools that are sending in the pixels can literally be anywhere, and it doesn't even have to be a school. It can just be like an enthusiastic person who wants to colour in 64 pixels. If you want to email me about it, that's the email address, and we're also on Twitter. And I'm hoping this will go well. So if it sounds like the kind of thing you'd be interested in getting involved with, let me know, because we're kind of looking for people to get involved. If you know of any schools contacts that might be up for this, I'm definitely going to email the guy that made the gigantic Menger sponge in his school. And I think, yeah, that was what I was going to say. I was going to get one quick plug-in, which is that myself and Christian and Peter, who was briefly name-checked earlier, run a website called the A Periodical. It's exactly what it sounds like. It's a mathematical irregular news source, which is encapsulated in that name. But we write, it's kind of a magazine-style blog thing where we write pieces about maths, and we also take guest posts. So if anyone wants to write anything about any maths and find it published on the internet somewhere, I mean, I don't mean to blow my own trumpet, but we get like 1,000 hits a day, mainly because we wrote a post about the group theory behind the Rubik's Cube, and anyone who searches for how to solve a Rubik's Cube gets directed to that post and then goes, what? This isn't helping. But anyway, that is a thing that we do. So if you're interested in finding out about that, we literally were just sat there going, oh, we should have done a session on this. This should have been a whole 20-minute session, what writing a maths blog is like, but I'm really sorry we didn't do that. But otherwise, I'm going to shut up and go and drink some water. But thank you.